7.6 Rotations and rotational symmetry. So a few things to remember when we're talking about rotation. So a full turn. So if I go here and I go here and here all the way here, a full turn has exactly 360 degrees. So if I would start in the center here and look here and then rotate, say I was this person, I was rotating in a circle like this. To get back here, I will have rotated 360 degrees. So the way that we rotate things, and a simple way of doing it is a tracing of this shape right here is rotated about its center right here. We draw a line segment to help identify the angle, the shape turned through before it coincided with itself. So coincided with itself just means that it repeated. Okay, or the next shape was directly right on top of the original shape. So if we would take this one right here and rotate it 90 degrees down to here and draw the shape again. So we have here, and then draw the shape again here, and then draw the shape again, and then draw the shape yet again. We have a full 360 degree turn. Now if I were to start from the beginning here and draw it again all the way to the beginning, I will draw right back on top of the original shape. So that's how we know it's done. So before we draw on the original shape again, we get 1, 2, 3, 4. So a shape is said to have rotational symmetry when a shape is repeated and moved around the center and eventually covers the original shape. The number of times it takes for a shape to be rotated around through the center, or any given point really, we'll see an example of that, before it repeats is called the order of rotation. An angle of rotation of symmetry is the angle of the angle that the initial shape was rotated. So in general for rotational symmetry, the angle of rotational symmetry simply is 360, because in a full circle that's how many degrees there are, divided by the order of rotation. So we know that the angle of rotation of symmetry in this one is, well, we have 360 divided by 1, 2, 3, 4, because we said that it took 4 times for us to draw before we get back to the start. So the order of rotation on this would be 4. So 360 divided by 4 is 90, and look, that's what we initially rotated that shape around. So please note, shape cannot have a rotational symmetry of order 1. We can have 2. Okay, so if I have a shape that looks like this, and I rotate it, it's going to look something like this. So this would have a rotational symmetry of order 2 because it takes one shape and then 2 shapes to get back to the origin again, but something cannot have a rotational symmetry of order 1 because then it's just simply not rotated.